going and we're going to impact in the north or south pole of the moon. And when you make a big impact, you kick up a lot of dust and dirt and debris, maybe water ice if it's there. That's not a real reason for going. We're trying to see if there's water ice on the moon. So we have this impactor, and then right behind it, we have a shepherding spacecraft that follows and flies right through that plume and makes a bunch of measurements, sends them back to Earth, and we're going to use that data to try and determine if there's water ice up there on our moon.
Now, you said it was the North or South Pole, so has that decision been made yet?
Right, yeah, we're looking at candidate craters and regions in both the north and the south, and we're using all of the data from all of the international lunar missions that are out there to try and pick the best spot to impact. And the key is impacting in one of these places, these permanently shadowed regions, which literally have not seen the sunlight in billions of years, so therefore it's very, very cold and a very good place to trap water ice. And there's permanently shadowed regions at both the north and the south pole. So we'll be going to one of those areas, and that's where we'll be impacting.
What exactly is going to impact the moon?
We are actually taking the upper stage of the launch vehicle and driving that to the moon with the shepherding spacecraft. And then several hours before impact, the upper stage of the launch vehicle, the Centaur, and the shepherding spacecraft will separate. And then it's that Centaur, which essentially is a big empty metal can at this point, is what actually literally impacts the moon at 2.5 kilometers per second. So you've got a big hunk of metal that's slamming into the moon, and when you do that, you're going to kick up all the dust and debris, and that's what we're going to be measuring.
Wow. Are we going to be doing any damage to the lunar surface as that Centaur upper stage impacts the lunar surface?
There are impacts of this amount of energy that happen on the moon several times every month. And so when we impact, we'll create a new crater, but not a very big one compared to the size of the moon. So probably on the order of a third of a football field wide and about 16 feet deep. So that's not so large on the scale of lunar craters.
So you won't be able to see that on the telescope?
We think that if you have, a moderate-sized amateur telescope, 10 to 12-inch telescope or so, then you should be able to see some of the impact.
Cool.
Wow, that's
so that'll be really great. So it's a good opportunity for people to go out in their backyards and do some observing.
How high off of the surface is this impact supposed to throw the debris, and then how far trailing behind the impactor will the spaceship fly through the debris?
Yeah, so most of the debris will be within 10 kilometers of the surface. So compared to the size of the moon, that's not too high. And the shepherding spacecraft that's following behind is only 4 minutes behind that first impactor. So we talk about this a lot on the project, that there's 4 minutes to collect all of this data. So it's a really important 4 minutes. And it's a lot of work for 4 minutes worth of data, but we're going to learn a lot.
Now, I know that NASA is looking at the potential of Shackleton Rim Crater as a potential place for a lunar outpost. Will that impact affect that crater, or is that going to be far away from that region?
Well, we haven't located the final impact location yet because, like I said, we're taking in all of the data from international missions and from NASA missions. And then when LRO gets there, too, we'll have several months of LRO data to further refine the impact point. So there are candidate craters, but the exact location hasn't been decided yet.
Well, it's kind of like, landscaping. If it's nearby Shackleton, you might say we've got this really nice aesthetic LCROSS crater that's near our driveway or something. I mean, it could be a little like that.
Is LCROSS going to go ahead and map this pre- and post-impact?
Actually, LRO will. Yep, LRO will take data before and then also after. So you'll get some, before and after shots, and also some of the other international missions that are there too. And we'll be comparing what happens, what we observe from the LCROSS impacts with previous data, with hydrogen maps and where the permanent shadow is, and try and combine as many data sets as we possibly can. And we also have professional and amateur astronomers right here on Earth that will be collecting observations too. So all of that will be folded in, and the science team is going to be looking at all of that data to try and learn as much as we possibly can from this experiment.
You mentioned the international data that's being gathered. Are you then going to take that data that we get from LCROSS and then share that with international partners as well?
Absolutely. Yep, it's a two-way street, and so we're already working with international scientists as well, and looking at their data sets, and they're going to be able to look at our data sets, and it's all just part of putting it under this big umbrella of broadening our scientific knowledge and learning as much as we can.
I can't wait.
Yeah, I'm looking forward to it. It's going to be cool to see it impact the surface.
We're going to have to get a little amateur telescope, put it up on top of the studio, and see if we can watch it happen.
That's right.
Live.
Yeah, it's going to be really awesome.
Well, Jennifer, I want to thank you very much for taking the time out of your busy day to help us out and learn a little bit more about LCROSS.
My pleasure. Thanks for the opportunity.
All right, we'll talk to you soon.
Okay, thanks.
Thank you.
Perfect. Do you hear what she said? She said 4 minutes of data. I mean, it's a very